In this video, we're going to do two examples where we draw a tree diagram to illustrate the outcomes of a probability experiment. So a tree diagram is just a picture that consists of branches, and each branch corresponds to the outcome of two or more probability experiments. So it's basically just a picture that illustrates this experiment. So in example one, we're going to use a tree diagram to create the sample space for the sexes of 3 puppies born in a litter. Then find the probability that all 3 puppies are the same sex, that is, all boys or all girls. So the first thing to note is you can do your tree from left to right horizontally, or you can do it vertically top down. Either is fine. So in this case, I'm going to do it from left to right and do a horizontal tree. So I'm going to start, I'm just going to put a dot, and this represents my starting place, and then I'm going to draw a branch that represents my first puppy. So my first puppy could either be male or female. So this represents puppy 1 here. And then my second puppy could either be male or female. So I continue and I say, well, if my first puppy's male, my second could either be male or female. If my first puppy is female, my second could either be male or female. So this second layer here is just puppy 2. And then my third puppy, I'm going to come off of each of these branches and I'm going to put 2 more. So male, female, male, female, male, female, male, female. And so this third layer here, this is puppy 3. Okay, and so I can use this to write out the sample space. And the way that you do that is you start at the beginning. So you start where this dot is here and you go through all the different scenarios. So for example, you go male, male, male. This is one outcome. And so I'm just going to write down male, male, male. I like to check off the end of the branch when I get through that one path. Okay. And so then the next thing that I could do would be to go down male, male, female, and I'll check that one off. So male, male, female, and then male, female, male, male, female, female, and then female, male, male, female, male, female. Oh, and I said that I check them off, but I forgot. There we go. Female, female, male. Check that one off. And then female, female, female. And you can always double check if you forget to check them off like I did. You can just count the ends of the branches. So 1, 2, 3, 4, 5, 6, 7, 8. That tells you there should be 8 total possibilities. And then just double check your sample space as 8. So 1, 2, 3, 4, 5, 6, 7, 8. That's a really quick way to just double check. And then we're going to do the follow-up probability question. What's the probability that they're the same sex? And so we would look at the total possibilities, which is 8. That goes in the denominator. And then we would look at which outcomes correspond to same sex. So male, 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 or female, female, female. And in this case, there are 2 options, so 2 out of 8, and we've reduced to 1/4. Divide both of these by a common factor of 2. So we could either say 1/4 or 0.25 would be the probability of having a litter that's male, 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 or female, female, female. Okay, so let's look at one more tree diagram example. In example 2, a coin is tossed and then a die is rolled. So when it says die, assume this is a 6-sided die with those outcomes. Use a tree diagram to demonstrate the sample space of the experiment, and then we have a follow-up question. So I'm going to start by just putting a dot here, and I'm going to ask myself, well, how many options are there if I toss a coin? Well, there are 2 options, and I could toss a heads or I could toss a tails. Then after tossing the coin, how many different options are there for rolling a die? Well, each one of these has 6. So I could get a 1, a 2, a 3, a 4, a 5, and a 6. And the same is true if I roll or if I flip a heads or a tails first. So I could get a 1, a 2, a 3, a 4, a 5, and a 6. And then to do the sample space, we could just list this all out, and just like before, you start at the front and you just go down each pass. So you could get a head and then a 1, so a H, a 1. You could get a head and then a 2, so H2. And I'll just check these off. A head and then a 3. A head and then a 4. A heads and then a 5. And then a heads and then a 6. And then I could get a tails and then a 1. A tails and then a 2. Could flip a tail and then a 3. A tails and then a 4. A tails and then a 5. And then a tails and then a 6. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 total possible outcomes. And if we count the ends of our branches, we should have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we do. So that's a really good way to double check your work. And so now let's follow up with our question. So what's the probability of getting heads on the coin and an even number on the die? So shorthand notation might look like this: head or even. So I know it's going to be out of 12 because there are 12 different choices, and I'm just going to go through and I'm going to circle all of my outcomes that have a head and an even number. So like a head and a 2, a head and a 4, and a head and a 6. So there are 3 different outcomes that give me a head or an even. So my probability of that is 3/12, or I could divide those by a common factor of 3 and get 1/4 or 0.25.